Practical demonstrates the effect of temperature on metabolic rate. A simple way of doing this is to measure the oxygen consumption. In this case we're using locusts. I'll get one of those. Measure the oxygen uptake. We put them in a tube. Okay. And then seal it so it's airtight. The white stuff in the bottom of the tube is soda lime. It absorbs any CO2 that the locust produce when it's respiring. To measure the amount of oxygen uptaken, if you place it in water, this water bath is at 20 degrees C. So when it's placed in the water bath, it should be left for about 5 or 10 minutes for the locust to reach the ambient temperature. Okay. If you then place it in the water, there's a small meniscus. Water is drawn into the tube as the CO2 is absorbed by the soda lime. So the amount of water that is drawn into the tube is the same as the amount of oxygen used by the locust in respiration. So you would then time it for 30 minutes, taking a reading of how far along the tube the meniscus has moved in 30 minutes. You'd record it every minute.
And because this uses a thermostat to maintain the temperature, there'll be slight oscillations around a mean temperature, for example the 20 or even the 30 degree. So we need to set up a thermobarometer, which is basically the same as that but without the locust inside, to be able to calculate the slight changes in oscillations in a given minute. So we set this up exactly the same as with the locust, and put that in, and take readings from the meniscus every minute along with readings from the locust, and the difference will have to be added or subtracted from the difference for the locust, depending on whether there's been a net gain or a net expansion or contraction of gas within the thermobarometer.
Once you've gathered the data, you construct a table similar to this. Here you have your time in minutes at which the data was taken. You would then record locust 1 followed by thermobarometer. Here in the actual volume for locust 1, you write down where the meniscus was at that time. So here it was 96, 82, 73. It's going down because oxygen is used by the locust. Here, change in volume, you would subtract the given value, in this case 0.73 from the original value, 0.96, giving you 0.23. It's an approximation of the O2 uptake from the locust. To take account of the oscillating temperature and the effect that has on gas volume, you would use the thermobarometer data. You plot the actual volume of where the meniscus is in the manometer here, and then that gives you the volume and how it changes. To calculate the actual change in volume, you subtract the initial value from the given value for that time. So in this case you've got 0.95 as your initial value, 0.93 as your given value. So your change is minus 0.02. They may be plus or minus if the temperature varies around. So the gas may contract in this case, giving you a smaller, a negative change in volume, and expand, giving you a positive change in volume. To calculate the actual O2 uptake of the locust, you would add the change in volume from the locust column to the change in volume from the thermobarometer column. Therefore, you've taken account of the locust respiration and the changes in temperature.
I'll now illustrate what to do with the O2 consumption data. I'm drawing the graph from scratch, but you'll use class data in Excel. Y-axis. And O2 consumption in milliliters on the Y, and time in minutes on the X. Right. These are two sort of rough examples for 20 and 30. They might actually have no bearing on the actual results, but it's just to explain. And you'd have to calculate the O2 consumption rate at each temperature by dividing the Y value by the X value. Y over X. And you have to ensure you relate this distance to the Y scale and the X scale, so the units will be milliliters per minute. And we've now calculated, you will have calculated the O2 uptake in milliliters per minute. However, the locusts are different weights, so you have to divide whatever value you get by the body weight of the locust that you used.